Oh, eternity.
Alright. Well,
Hello.
No, wait.
while the technology is
Thy kingdom
fixing itself,
come back.
so, the thing to remember, everybody, okay, is that the sine and cosine, or the secant, cosecant, tangent, cotangent graphs are all related. Okay? So they're all kind of together, and then on top of that, the tangent and cotangent graphs go together. Okay, so all four of those. So the sine, cosine, cosecant, secant, those four go together, and then tangent, cotangent go together. So that's the relationship between the six. Okay, so that's the first bit of what we're going on. Hey, now everything's working great. Excellent. Okay. So the other thing to remember is that when you have to graph things like the secant, cosecant, cotangent, you have to enter them as 1 over their regular counterparts. So remember, cosecant of x graphs as 1 over the sine of x. The secant of x graphs as 1 over the cosecant. 1 over the cosine. Excuse me. Of x. And finally, the cotangent of x graphs as 1 over the tangent of x. Now, you do have to occasionally be careful with these things, especially when you're entering them in a calculator, because you could have a situation where something like the cotangent, for example, it really only happens with cotangent and tangent, where if I'm trying to solve a cotangent where the tangent's undefined, it could throw this thing off, because the calculator is going to read, for example, if I looked at the cotangent of pi over 2, okay, that's equal to 1 over the tangent of pi over 2, and the tangent of pi over 2 is equal to, it's undefined, 1 over 0. So this thing would be written as 1 over 0, okay? Now, the calculator is going to read 1 over 0 as being undefined, because it should be. However, the cotangent would just be 0 over 1, which is just 0, okay? So keep that in mind, that you can run into issues, and it only happens with the cotangent. It doesn't happen with the secant or cosecant, okay? It only tends to happen with the cotangent. There are a few places where the cotangent, when the calculator ends up acting funny, okay? So it's just something you have to know.
So basically, when that happens, when something is undefined, we check if it's not.
You check to see, is it really a case of it being undefined, or is it a case of it just being a calculator artifact, okay? Some calculators, too, will actually correct for that, okay? Because it kind of realizes you're doing the cotangent. So it's just something to keep in mind, okay, when doing these things. All right. Let's go ahead, though, and look at how to do some of the graphing that we saw the other day, okay? So basically graphing, things like graphing the cosecant, secant, tangent, and cotangent, okay? Graphing the four that we've seen before, okay? So yesterday we saw how all the pieces work with it and how you could form the basic graphs. Today what we're going to look at is actual graphs of these things, okay? Kind of take it from homework problems, all right? So let's start off with the first one here, okay? So let's look at, here. Oh, let's do a good one. Let's look at, we'll do, this will be number 19 from the homework, okay, or 19 from page 316, okay? So this is going to be y is equal to 1/2, okay? The secant of 2x minus pi, okay? All right, so the first thing we want to do is we want to go through, just like they do with the sine, cosine, and find all the bits and pieces of it before we start drawing our graph. Okay? So, the first bit we want to find is what?
Amplitude.
Amplitude, okay, so let's find the amplitude first. What's it gonna be?
1/2.
Just 1/2, that's easy enough. Is there any vertical shift?
Nope.
No. So there's no vertical shift, so the sinusoidal axis will be 0. So you can write this as none, or if you want to, you can write it as y equals 0, okay? Alright, what's the period gonna look like? Okay, it's gonna be 2 pi over 2, right?
Yeah.
Okay? Because again, secant and cosecant have the same period as sine and cosine. Okay? So my period is going to be 2 pi over 2, so just pi. And finally, is there a phase shift? Yeah. So the phase shift happens as a solution to 2x minus pi equals 0. That gives me x is equal to pi over 2. So my secant graph is going to start at pi over 2 instead of at 0. Okay? Everyone catch that?
Yes, sir.
Alright, so let's go ahead and graph this thing out. Okay? We're going to graph this thing for one cycle. Alright, so sinusoidal axis is the x-axis, so we don't have to worry about that. Okay? The phase shift, it starts at pi over 2, so we'll go ahead and mark that. Here's where pi over 2 is going to be on this graph. It repeats every pi. So it's going to get all of its business done in distance of pi. So what's pi over 2 plus pi?
Pi over
3 pi over 2, right? So we'll come over here and mark this as 3 pi over 2. Okay? Then we know halfway between, it should have something important happen. What's halfway between pi over 2 and 3 pi over 2?
2 pi.
2 pi over 2 are just pi.
Pi. Yeah.
Okay? And we know special things are going to happen with the quarter marks as well. So what's so you can think of that as being halfway between pi over 2 and pi. It's going to be what?
3 pi over 4.
3 pi over 4. And halfway between pi and 3 pi over 2 is going to be?
7 pi over 4.
5 pi over 4. Okay? 7 pi over 4 would be
Yeah.
the one that's immediately after 3 pi over 2. Okay? So those are all going to be all the locations where interesting things will happen. Okay? Now, next, okay, so that takes care of our period, that takes care of our phase shift. Our vertical shift, we don't have to really worry about it, it's been taken care of. Next is amplitude. Amplitude is 1/2, so that means
You go 1/2 and down.
I'm only going to go up 1/2 here. So we'll call that 1, there's 1/2. Or down minus 1/2, there's minus 1. So, I'm going to go ahead and just draw these axes out. So I know, because I know that's where the thing is going to, the secant graph is going to touch. The minimums and maximums are going to be along those lines there. Okay? Now, here's the next thing. This is the secant graph. So it's going to be the cosine graph turned inside out. Okay? Does the cosine start at the sinusoidal axis, or does it start at maximum or minimum?
Maximum minimum.
Maximum or minimum. So secant's going to do the same thing. So my first point of my secant is going to be right here at pi over 2, 1/2. Okay? Alright? And then it's going to have an asymptote at 3 pi over 4. Okay? It's going to have another touch point right here at pi minus 1/2. Okay? Then an asymptote at 5 pi over 4. And finally it comes back home again, 3 pi over 2 is finally where the sequence will end there. Okay? And remember, it's going to form like little parabola curves in between there. Okay? And so there is one full cycle, yeah, that's fine. One full cycle of the secant graph, okay, as written. And if you want to, because you know what this thing should do, we know it should come up like that there, and on this side too, should come up like that there. And so you could go a little bit further along the graph if you wanted to. But basically, you were just kind of filling in the gaps, okay? Everyone see how that worked, and why that was the case? Okay. I'm seeing a lot of nodding heads, and I'm hoping if I ask you guys to do this on the board, y'all would have no problem. Okay. We'll look at another one though before I have you guys volunteer, force to do these on the board. Okay, but that's essentially it. Okay, so again, a lot of times when you're graphing these things by hand, it's knowing where important points happen and sort of marking off axes and things like that that you can use as reference. Okay. The other thing you could do here as well, okay, if you wanted to add it just for the heck of it, you could throw the cosine graph on here. That is the cosine with all the same parts, okay? So I could kind of go through here, and in this color here, I believe it's blue, in the blue,
All right.
yes. It's going to, we're going to do 1/2 the cosine of 2x minus pi for reference, okay? And if you note here, it's going to start right there, cross, touch, cross, and touch again, okay? So, basically, wherever the cosine has a 0, or cosine returns to the sinusoidal axis, the secant has an asymptote. And wherever the cosine has a maximum or minimum, the secant has a maximum or minimum. Or actually a minimum or maximum, because that's technically a minimum there, because it's the bottom of
That's
that
critical
curve.
point.
Okay. Yes?
Isn't that also a sine graph?
It's also the same as a sine graph, because remember, the sine and cosine, sine and cosine, they differ. Thank you. Take that. Okay. They only differ by the way, here's your unit circle. It's like a few days ago. The one you took last night. They only differ by a phase shift from each other, so they're literally the same thing, just different. A small change in phase. Okay. Oh yeah, in this particular case, that does look exactly like the sine graph, except I've squished its period down. Okay. So if I wanted to, I could say in blue that the same thing is 1/2 the sine of 2x. It would give me the same exact graph. Okay. But that's how you would approach one of these things. Okay. All right. Now let's say that was a secant dash cosecant graph. Oh boy, excuse me. Let's look at a tangent one, okay? Tangent dash cotangent graph, okay? So we can get the idea there. Let's choose a good tangent graph. Oh, this is a good one, okay? Trying to pick a good one. Yeah, tangent and cotangent graphs on this page are rather lacking. Oh well, just choose one. Or I'll modify it. There we go. So let's look at 2 y equals 2 cotangent of x minus pi over 2 plus 3. Okay? Now, just as before, we're going to go through, and before we do any graphing, let's find all the parts of this thing. Okay? First part's going to be what?
Amplitude.
Amplitude. What's my amplitude going to be in this case?
2.
Just 2. Now, the amplitude here, remember, doesn't tell me how far up or down I am for the sinusoidal axis. It tells me how much I'm stretching my cotangent graph. So everything's going to be stretched by 2. Okay? Alright, next, we want to figure out what the sinusoidal axis is. Okay? Or the vertical shift, what's that going to be? Plus 3. So we're going to say y equals 3 is where that axis is. Okay? Next, let's do period. What's my period going to be? Okay. Now, for the sine, cosine, secant, cosecant, it's 2 pi's over b is the period. But for this, it's pi over b. Okay? Is there any b given? Nope. So my period is just pi. Okay? And lastly, where's the phase shift? It has a phase shift. It's been phase shifted over by pi over 2, positive pi over 2. So, positive pi over 2 is where the thing's going to start. Okay? So now I can come through and start graphing this. Okay? Excuse me. The thing has a phase shift at pi over 2, so we're going to start at pi over 2. Right here. Okay? Its period is pi, so it's going to repeat again at 3 pi over 2. And have a center of pi. Okay? Other features, just to help me with graphing, I'm going to go ahead and add on here 3 pi over 4 and 5 pi over 4. Because those are going to help me be able to draw this thing better. Okay?
How are you able to determine that the next point would be 3 pi over 2?
Oh, I did pi over 2 plus pi. That's how I knew. So when you're finding the basically where to start and where to end, you just add the period to your phase shift. So I started at pi over 2. I added pi. That's how I got that point. And then filling in the center is just always half, and then halfway for tangent and cotangent, only the halfway mark really matters. I just put those in there because they're going to help me with my graph. Okay, when I actually graph this out. Okay. So we go ahead and we mark that. That takes care of period and phase shift. Those are taken care of. Vertical shift is the next thing. Our vertical shift is plus 3. So I'm going to come up here, 1, 2, 3, and I'm going to go ahead and draw a dashed line there. Okay, and label those y equals 3. I do want to point out here, my scale, my x and my y are not exactly the same. Because technically pi would be 3.14, and so that's a distance of 3 there. Well, actually, it's not so bad, I guess. I guess it did okay. But still. And it's okay if you're graphing these things if you don't get the scale of x and y the same. Just make sure you label things, okay, so it's clear that what you're talking about. Like, I labeled that as 3, so I know that that is where y equals 3 is. So that would mean that's 2, that's 1, okay? Just like I labeled down here what things were. It's very hard to try to make these axes have the same nice, clean dimensions when you're dealing with things like pi, etc. Okay? Alright, that takes care of that. Alright, now it's time to get graphing. The cotangent, okay? How does it start? Does it start on the line or does it start someplace else?
Someplace else.
Someplace else. In fact, it starts with an asymptote, if you remember, from yesterday, right? Okay? It was an asymptote that ran down, and it started high and ended low. So, pi over 2 is actually going to be an asymptote, okay, of the cotangent. 3 pi over 2 is going to be the other asymptote, where it ends. Okay? Pi is where the thing returns to the sinusoidal axis. That's where it's going to become, have it 0. Or, I shouldn't say 0, but have instead its point where it goes to that center axis that it does its wavy thing around. Okay? So right there would be kind of the center point here. We'll call this pi 3. Okay? We have an amplitude of 2. That means everything's going to be stretched out by a factor of 2. How I'm going to indicate that is the reason I marked 3 pi over 4 and 5 pi over 4 is those quarter locations in between everything, that's going to be where the cotangent would normally be equal to 1 or negative 1. Okay? In this case, because I have an amplitude of 2, it's not going to be 1 or negative 1, it's going to be 2 or negative 2. Does that make sense to everybody? We're stretching it out by 2. So I go 2 up from here, so 4, 5. Put that right there. So this would be 3 pi over 4, 5. And 2 down from here. So right here, 5 pi over 4, 1. Okay? And okay, let's do that better. Whoa, go back. Did I just, there we go. Okay. There you go. That looks a little bit better. And so it's going to be kind of a stretched out, long thing, thin, like that there. And if we wanted to compare it to the, with a graph, we can see that. So, so if we compare it here, could actually take a look at what it looks like. Okay, so it was 1/2 the cotangent of x minus, what was it, pi over 2?
Yep.
Oh, that was
Plus 3. And if you see here, that's exactly the curve I made up here. So let me go ahead and just throw up the line y equals 3.
Wait, was the amplitude a half on this one? Or was it 2?
Oh, it was 2, you're absolutely right.
That's pretty.
There we go, that's a little bit better. And we'll make this. Okay, y equals 3. And if you look here, we graphed, basically what we graphed was this one that's right here. Okay? And if you look here, that point's pi 3.
Sweet.
Exactly what I got right there. Okay? I had, I said there would be a point right there at, come on. Wow, this thing's being stubborn. Anyway, there should be a point
At minus.
right here that's at, where is it? Actually,
Yeah.
so right there. Come on. Right there, 2.3565, basically.
Wait.
Well, 2.356, that's 3 pi over 4, okay? And I just did it in my little handheld calculator here to show that it's 3 pi over 4. And then down here at 1, okay? Come on. Right there, 3.926, that's basically 5 pi divided by 4, okay? So the locations I marked off to help me graph are also up there. Unfortunately, the thing won't show it to me nicely, okay? The other thing is you can see how it has asymptotes kind of approaching certain locations, like pi over 2, okay? You can see how it's beginning to kind of go asymptotic right there. Same thing with 3 pi over 2, okay? And so you can kind of see from the graph how we did things correctly, okay? All right, any questions about how graphing works? Everyone see how it goes? All right, let's get some volunteers, okay? Let's get somebody to do, because it's not, I can sit here and graph these things all day.
Jake.
Then
Jake.
I know how to graph.
Jake.
All right, guys.
I did it last time, bro.
Okay.
You need to do.
Drew, you did it last time. So let's do, graph. Okay. I want someone to go ahead and graph for me. The secant of pi x minus 3. That'll be our first one. Our second one, let's have somebody graph 3 cotangent of pi x. These are too easy.
Yeah, that's pretty.
Yeah, all these are way too easy. I mean, the book just kind of sugarcoats these. And the last one, cosecant 2x minus pi. Okay? All right. Volunteer for the first one? Anybody?
I'll take number 2.
All right. Thank you. Now volunteer for number 2. Volunteer for number 1.
There's no horizontal.
Anybody? What would you pick?
I can do it, but I've done
You
one.
did one last
Yeah.
time.
I did one last time.
You did one last time
I
too.
sort of did.
I did
Okay.
one last time.
Come on, Nick.
Oh.
Okay. I'm gonna pick on you. Warner, do the first one. Okay. And Lee, do the last one. We'll pick. If you guys don't volunteer, I just pick on you. It's going to be completely random.
Well, if we're not raising our hands, I you don't know
There's the face.
Here, a little bigger.
And the second one.
Okay. You're doing one.
And it's only.
Stop publishing what videos? Naughty videos? Is that what I heard?
Jake.
Ah.
One part.
Are you feeling it now, Mr. Krabs? It's Jake.
Wait, are you guys gonna? Wow, that's pretty close.
Yeah, you might want to give yourself some space. There is like a million different whiteboards in here. There we go. Ah,
Dowell. Period, and this one be pi.
which one? Let's see, you're doing the center one?
Yes.
Period. It's pi divided by pi.
2 pi over pi.
That's for sine and cosine. But for tangent, cotangent, it's pi over b. So this would be pi divided by pi. So period is just 1.
Shouldn't the vertical shift be 3?
For what, number 2? Nope. There is no vertical shift.
What's that?
There is none for 3 either, right?
There is none for the third one either.
Oh, but how do I find the period?
The what? Period. Okay, for secant, the period is 2 pi over b. So what's b?
1.
No? What's in front of that x there? Pi.
There's no phase shift here.
2 pi over 32.
So it's 2, yeah. Yep. If it's not there, it's 1. If it's being, unless it's being, okay. So if it's not there for amplitude or period, it's 1. If it is there, if it's not there for vertical shift or phase shift, it's 0, basically. Okay. So yeah, this thing has no phase shift, no vertical shift, no phase shift.
How do you find
Yeah.
period for the
Cosecant has the same period as the sine, so it's 2 pi over b. So what's your b? Huh? Nope. Oh, you mean the period totally? Not 1, but it's 2 pi over 2, right? So it'd just be pi. There you go. Okay, the second one has no phase shift because there's nothing being added.
Can this be considered 2 pi since
Wait.
since 1 is the coordinate for
No. These coordinates have nothing to do with that.
Okay.
This one, okay? There's nothing being added to the to the inside there. So you see where it says pi x?
You use radians in the last cotangent problem.
Yep, you use radians here too.
So like
I'm sorry, but like,
this would be
no
pi over 2.
Okay.
Carl, no help. On the beginning.
no, or,
So I've got 1 in the middle.
Right.
I need,
So
I mean,
0.
Yeah.
that's my problem,
The thing starts okay. The thing starts at 0 and has a period of 1. So it starts at 0, ends at 1. Okay. And then what's halfway between 0 and 1? 1/2. What's a quarter?
Now, what's the period for?
2. So pi. This one's difficult. It starts at pi and repeats not at 2 pi, but at pi plus 2.
Mine was, where do I start? I mean, I know a period is pi.
Your period is pi, so it gets all its business done, and it starts at 0. Or no, its period is pi, and it starts at pi. So your next, it would repeat at pi plus pi, which is 2 pi. Yep.
Is this pi plus 4 or pi plus 3?
It'd be pi plus 4.
So this
Okay.
is pi plus 1?
Yeah.
The middle numbers would just be like
So it's half. Yeah, it'd be 3 pi over 2.
oh wait, the first one.
Okay. Well, that comes from knowing which one you're doing. Okay? You're doing, in this case, a cotangent, so it starts with an asymptote. So where does this thing start?
0.
So 0, there's a vertical asymptote at 0, and there's a vertical asymptote at where it ends, which is 1. Okay?
This starts at a.
Okay, so secant, yeah, starts at the maximum, okay? So,
So I have like a point here. So we'll just be like.
Not none.
okay, that would be if it was a cosine, but it's not. Secant, remember, the secant here, let's go back one here. The secant here is the one that's in whatever color that is.
Red?
Yes. And so, remember, they always forms the U thing. So if it starts at pi, okay,
So we'll be like this.
yeah, if it starts at pi, where its vertical shift is -3, so go down -3. Okay? And so, and our amplitude is 1. So actually, you might want to actually, because you're going to run out of room down here, shorten this axis, basically. So, leave that there, just let's go ahead and just redraw this axis, and just make the spaces smaller, so that way you can get the whole thing off. Okay? Yeah, so go down, it's really all it says. So, 1, 2, 3, and then 4. That's fine. Okay. So we have a vertical shift of -3. So your sinusoidal axis is at -3. So go ahead and put a dashed line there. Across. Okay. Your amplitude is 1. So that means the maximum and minimums are going to be located 1 up and 1 down from this line. So -2 and -4. Okay.
Okay, so it'll be like that.
So yeah, except it starts at pi. So our first point will be right there.
Going down.
No. Up in this case. Because we're seeking.
Okay.
Because remember, it takes only U.
So start with 2.
Uh-huh. Yep. And that's actually an asymptote there. Okay.
How do you know where the asymptote is?
Asymptotes are going to occur basically, actually for these, they occur at the quarter marks. Okay?
Okay, every quarter mark?
Yeah. So at pi +2, it's actually going to be down here. Okay? And so we're going to have so 1 down. And pi +3 is going to be straight down. So there you go. Good. Perfect. That looks beautiful.
Okay.
Excellent. Okay. Actually, one thing. Yeah, your amplitude is slightly off. You did an amplitude of 2. When your amplitude should have been 3.
Wait, where?
See, you do 1/4 2, it should be 1/4 3, but that's okay. We'll just go. There we go. And that way you don't have to redraw.
Can we do that on the test?
Okay. But good. Okay.
Mine doing like, is it this? Sort of thing starting here, going down, back up.
Nope. Okay, so remember these things make U shapes.
Oh, so this is the parabola.
I don't care.
Okay. So yeah, it's the parabola one.
I
So
get those mixed up.
yeah, it's going to have, cosecant starts with an asymptote. There's going to be an asymptote here at pi/2. Wait, I started at the phase shift is pi/2. So, go ahead and put pi/2 right here. That's actually where it starts. Okay. There's an asymptote there. And an asymptote at 3. Okay. Okay. And so you're going to have one U right there. And 2 pi, yeah, down here on pi, the line.
So every middle difference.
Yeah. I think that's good enough. Okay? Perfect.
Like 4 days ago already.
All right. Everyone got how that works now? All right. Okay, I believe it's already 11 o'clock. All right, y'all are done. So go ahead and get on out of here. So that is the correct cotangent graph done right there.
Make sure y'all read.
Okay. This is the secant graph. There are a few. There is actually an arrow of this one, but the general. Where is it? The general picture. Sorry. General picture should be there. And that cosecant graph, which came out perfectly fine. Okay? All right.